Welcome to Week 10. This is your statistics instructor, Dr. Todd Daniel. And this week, we're going to be talking about hypothesis testing using one-sample t-tests. And I'll be explaining why we're looking at a picture of St. James's Gate in Dublin, Ireland, the home of the Guinness Brewing Company. And it all has to do with a story that goes back to the beginnings of statistics. Let me tell it this way. We have a problem with that z-test that we learned about last time. When we have a z-test, we need to know something about the population. And specifically, we need to know the mean and the standard deviation of the population. If we have both mu and sigma, then we can use a z-test. But the question is, what if we don't know the standard deviation of the population? Because most of the time, we don't know the standard deviation of the population. What do we do then? This creates a bit of a problem. Well, we might solve this problem simply by using the sample standard deviation in place of the population standard deviation. We already know that we use the sample mean as a representation of the population mean, so why not do the same thing with the standard deviation? And the answer is we can do that. However, it changes the nature of the test. And the test becomes something different than what we started with. So notice in these two formulas, one for the z-test, one for the t-test, in the z-test, the standard deviation of the population, or sigma, goes in the denominator. As you look at the t-test formula, you'll note that it is exactly the same as the z-test formula. No difference except for this SD, that's the standard deviation of the sample. So we see that the sample standard deviation has been plugged in exactly the same place as the population standard deviation. It's just that now the test has become something different, and here's why. If we were to go back to sample variances, the SD squared value, what we would find is that a distribution of those values is positively skewed. Now, why would these values be positively skewed? Well, because they're squared. So it's going to stack up the values on the lower end of the distribution, fewer values on the upper end. It's going to pull the tail out in the positive direction. So what this means to us is that if we use those positively skewed sample variance values in our formula, it will underestimate the value of the variance in the population. And this will increase the value of t in our formula. So what I'm showing you here are two distributions, a z distribution and a t distribution. So let's look at that z distribution first. Where would we find our cutoff value for 0.05 or 1.96 standard deviations? We'll put it roughly right there. I've drawn a line horizontally so you can see that in the t distribution it's going to be pulled out further to the right. So let's just focus on the intersection of the purple line and the black line, and we'll draw a line straight down from there. That is the value of z for alpha equals 0.05, which we already know is going to be 1.96 standard deviations. But with that exaggerated t distribution, what will be the difference with the t value? It is going to be pulled out to the right. See where the black line crosses the green line? That value is greater on the x-axis than the z value. And we have another problem. The amount of the deviation of the t value from the z value is a function of sample size. The smaller the sample size, the more that t deviates from the z value. And this is a problem. Fortunately, this problem has been solved for us by this handsome young man, Mr. William Seeley Gossett, a statistician employed by the Guinness Brewing Company in Dublin, Ireland. As a statistician, Gossett was working with very small samples, batches of beer. And what he determined was that the small sample sizes he was using were distorting the values that he would have gotten from using scores like a z value. And so he came up with a correction for this problem. Unfortunately, he was not able to publish under his own name because of a prohibition by the Guinness Brewing Company, and so he published in Fisher's journal Biometrica under the pseudonym Student. And so we now talk about the student's tea distribution, or perhaps a studentized range, all going back to Gossett. The t-test, the student's t-test, uses sample variance as an estimate of population variance. And as such, it uses n-1 in the denominator. So we can use student's t-table in order to find a critical value for any t-test. And student's t-table is the gift that Gossett has given us. And we will learn how to use it as we learn about one-sample t-tests.